Hey guys, welcome to Basic Physics Creators channel. I hope you are all safe and good. Today we are going to discuss about the topic light. If you want to watch this video in Telugu, please check the video description for the link. When you listen the word light, so many questions raises in your mind. Am I right? What is light? What are the properties of light? What's the wavelength of light? What are the applications of light? Blah 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 blah. So don't worry, I will give answers to all your questions. Let's get started. Light. Light is a form of energy that the life of this planet Earth is depend on. If we are able to see the beautiful nature around us, it's only because of light. That is, getting reflected from the objects is received by the optical nerves in our eye within 1/16 seconds from the objects around us. Now let us get an idea about the light, its properties and its nature. As I said earlier, light is a form of energy and the energy can neither be created nor be destroyed. One form of energy can be transformed to other form. So in this manner, light can't be created, but some form of energy can be transformed to light energy. Light is generated by the luminous object and travels in all directions, but in straight line. What's luminous object? Luminous object is nothing but the object that gives out light on its own is called luminous object. For example, sun, stars, etc. This form of energy can be the main source for photosynthesis in plants, vision, generating electrical power, and so on. Objects are classified as transparent, opaque, translucent based on the material allowing the light to pass through them. So, what are these objects? Let us know. Transparent objects. Transparent objects is nothing but objects that allow the light to pass through them is called as transparent object. For example, light, air, glass, water, etc. Opaque. Objects that do not allow light to pass through them is called opaque objects. Example, wood, human body, etc. Translucent objects. The objects that partially allow light to pass through them is called as translucent objects. For example, oil patch papers, tracing paper, etc. This light or visible light is a small portion of electromagnetic radiation that our eyes can detect. The wavelength ranges from 400 nanometers to 700 nanometers in the entire electromagnetic spectrum of range 10⁻18 meters to 100 kilometers. So it's the tiny portion of the entire range of electromagnetic spectrum we are able to see. There are different sensors in electronics to detect other parts of electromagnetic spectrum. And our eye is the sensor to detect the visible light. When light interacts with some matter, it shows some properties. So what are the properties? The properties like reflection, refraction, interference, diffraction, dispersion, and polarization. So let's go to these topics one by one. What is reflection? Reflection means this is the phenomenon of light rays bouncing back into the same medium after striking a smooth surface is defined as reflection of light. If a perpendicular line is drawn from the smooth surface, then the angle of reflection is equal to the angle of incidence with respect to the normal. This is called as law of reflection. We have three types of reflections: regular reflection, diffused reflection, multiple reflection. Regular reflection. It refers to the clear and sharp reflection like the one we get in mirrors, which is coated with a highly reflective material. And next, diffused reflection. Diffused reflection means when light is reflected from a rough or an irregular surface, then the reflected rays are not bright and intense. The light rays getting diffused. By changing the roughness of the object, diffused reflection can be achieved. Multiple reflections. Multiple reflection means light getting reflected back and forth multiple times between the reflecting surfaces is called as multiple reflections. This is used to create the optical illusions in bakeries and saloons. Reflection is used to see the objects around us. Reflection is used in refractive type of telescopes. And next, refraction. Refraction means simply we said that bending of light is called as refraction. So, bending of light rays as it passing between one transparent medium to other transparent medium. The law that governs this phenomena is known as Snell's law. The Snell's law gives the relation between the refractive index and the angle of reflection and refraction. That is, n1 sin I equal to small n2 sin r. I is called as angle of incidence, r is called as angle of refraction, n1 is nothing but refractive index of the first medium and n2 is nothing but refractive index of the second medium. Refractive index is given by the ratio speed of light in vacuum to the medium. It's nothing but n equal to c by v. What are the applications of refraction? The position of stars gets shifted because of the atmospheric refraction is one of the main applications in refractions. And interference. Interference is a phenomenon in which two waves superpose to form the resultant wave of greater, lower or the same amplitude. Diffraction. Diffraction means it is the spreading of waves around obstacles. The result of the action is that sharp shadows are not produced because interference taking place. The condition of diffraction is that the wavelength and the linear dimensions of the obstacle should be comparable. And next, dispersion. What's meant by dispersion? I simply said dispersion is splitting of light. So the phenomenon of splitting of white light into the constituent colors when the white light passes through the dispersing medium, then it is called as dispersion. This dispersion was discovered by Sir Isaac Newton. And polarization. Polarization means the process of transforming unpolarized light into polarized light is known as polarization. Since the light is an electromagnetic wave which is transverse in nature, the electric and magnetic fields vibrate at perpendicular to each other. In this polarization process, one of the components of the electromagnetic wave is filtered out by using this polarization filter. We use light to study the nature of matter. We use it to know the color of an object, how transparent it is, and how it reacts to the light. Some objects absorbs all light and appears as black. Some objects reflects all lights and appears white, and some absorbs fine part of the light and shows its colors. And then, what's nature of light? Nature of light is the biggest question for many years. In early 1800, when Thomas Young, Francis Argo, and Augustine Jean Fresnel showed the interference effect in light beams, showing the wave nature of light. This theory got accepted and treated light as composed of waves, but in the late 1800s, a problem raised when experiments is measuring the spectrum of wavelengths from the heated objects were studied. The wave nature of light could not explain the wave-based equations of light. This problem was solved when Max Planck proposed that the total energy of light is made up of indistinguishable energy elements or quanta energy. Einstein correctly distinguished the value of these quantum energy elements while analyzing the photoelectric effect. The energy of photon is calculated by using Planck-Einstein relation. Planck-Einstein relation we simply said E equal to h mu, where h is nothing but Planck's constant and v is nothing but frequency. For their work in this field, they got Nobel Prize in Physics in 1918 and 1921. From there onwards, light is started to be considered as consisting of particles of energy called as photons, which is smallest amount of electromagnetic radiation and is the basic unit of all light. These photons are always in motion and travel at the same speed of light. Quantum mechanics explains the both observation of wave nature and particle nature of light today. So finally it is concluded that the light has both wave and particle nature and hence it has dual nature. The famous theory of quantum mechanics got its origin when Planck took over to solve the discrepancy when the wave-based equations failed.
Here is one of the ways to convert light energy into electrical energy by using solar panels, and the principle behind it is photoelectric effect.
If you want deep understanding about the photoelectric effect, please let us know through the comments. Thank you for watching our video. If you like this video, please do like, share and subscribe to our channel. Hope to see you in the next video.